This is section 3.4, solving quadratic equations by factoring. All right, so solve quadratic equation by factoring. A second degree polynomial equation is called a quadratic equation. And this is what it looks like. A second degree polynomial equation. Okay, notice that it's in descending order, degree 2, degree 1, degree 0, and it's set equal to 0. A quadratic equation in the variable x is an equation of this form where a, b, and c are real numbers and a is not 0. We have to say a is not 0 because if you let a equal 0, well, 0 times x squared is 0. And notice how that takes away your x squared, so it's no longer a quadratic. So that's why we say that. So once we have that, since we're solving by factoring, we're going to factor this, and then we have to use the zero product property. The zero product property says that if you have two factors, factors are terms that you multiply together. If your factors are set equal to 0, then m has to equal 0 or n has to equal 0. So if m is 0, 0 times n is 0. If n is 0, n times 0, m times 0 is 0. Okay? So that's why that works. All right. So now here's what we do. We start off with your equation in quadratic form. So degree 2 polynomial, descending order, set equal to 0. We're going to factor completely, and we apply the zero product property. Set each factor equal to 0 and solve the resulting equation. So here's an example that they gave. 6x squared plus 11x equals 10. This is not in quadratic form because it equals 10. But that's an easy fix. So subtract 10, set it equal to 0. They factored it. Notice how it's still equal to 0. If you don't have this equal 0, well, then it's not an equation and you can't solve it. Okay, so you need this. If you don't have this, I'm going to take points off. All right, then you set each of these factors equal to 0, solve, and then you put your answer in the solution set. Okay. All right, now for number 12, 1, here we go. This is this is in quadratic form, degree 2 equation, descending order, set equal to 0. So we're going to factor this. Now, how are you going to factor? Well, that's up to you. You can guess or you can use the AC method. So I did in the chapter 2 review over polynomials. You might want to, if you're not strong with factoring, then you might want to watch the video over factoring polynomials, okay? But here I'm going to go ahead and guess. And the reason why I'm going to guess is because I look at the 5 and there's only one way for me to multiply two numbers to get a 5, and that's 1 and 5. Okay. Now I just need to think about what I want the 12 to be. And the two numbers that pop in my head are 3 and 4. So I'm just going to put a 3x and a 4x. Okay. Now, my goal, I'm going to check this. I have to check it. Okay. So I hope that the outer and the inner are going to get me 17 somehow. So outside is a 15, inside is a 4. Well, 15 plus 4 is 19. 15 minus 4 is 11, not 17. Okay, so 3x and 4x don't work here. So let's flip those two factors around. Let's put a 4x here and a 3x here. So the outside gives me a 20. The inside gives me a 3. 20 minus 3 is 17. Ah, that's what I want. Now, how do I get a negative 17 from 20 and 3? Well, that would mean that the 20 would have to be negative, and this is where you get the 20 from, so that's why the negative goes there, and then this would have to be positive. So then you set each factor equal to 0, and then solve. Okay, so our solution set is negative 1/4, comma, 5/3. And if I'm not mistaken, I believe this is how Alex is going to want their answers. Okay. All right. Number 2, 8x squared equals minus 6x minus 1. Okay. This is not in quadratic form. Quadratic form, remember, is a degree 2 polynomial descending order set equal to 0. Well, I can do that. I can either move this 8x squared over to the right, or I could bring these two terms over to the left. Now, if I bring the 8x squared over to the right, it's going to start off negative. And anytime we start off a polynomial with it being negative, it always brings about trouble. So we don't ever want to do that. We want to start off with our leading term being positive. So instead of moving it to the right, I'm going to move everything to the left. So we have 8x squared plus 6x plus 1 equals 0. Now, again, we got it in the right form. And I'm looking at this one. There's only one way to factor for me to get a 1. And the end would have to be the 1. So now I just need to get the factors to give me 8 that would add to 6. So that would have to be a 4x and a 2x. Since this is positive everywhere, there we go. And then I can double check. Outside is 4x, inside is 2x. 4x plus 2x is 6x. So we're good. Okay. And then you set each factor equal to 0 and solve. Okay. Negative 1/2 and negative 1/4. There you go. Okay. All right. Number 3. Now, when you factor, remember the first thing that you're always supposed to check for is, do you have a GCF? And in this case, I do have a GCF. My GCF is a 4. So I'm going to factor a 4 out. And that's going to leave me with 6x squared minus 2x. Oh, sorry. 6x squared minus x minus 1 equals 0. So here's the 4. And man, we lucked out again. There's only one way to get a 1. And then I need two numbers that multiply to 6 that can get me a 1. So that would have to be a 2x and a 3x. So I'm looking for a negative 1. So outside gives me a 2x, inside gives me a 3x. And the 3x is what I need to be negative. That one would have to be positive. So then as we set our factors equal to 0, well, 4 equals 0, that doesn't make any sense. So I just don't worry about it. And then I set these other factors equal to 0. And then I solve. X equals negative 1/3. Okay, so negative 1/3 and 1/2. And here are your two solutions. Okay. All right. Now, number 4. Now, number 4 absolutely is not written in quadratic form. In fact, we have to clean this up. This is one big mess. So we need to distribute. So this is going to give us an 8x squared minus 12x. Here's the 8x equals 12x minus 9. Okay. So we're going to clean up the left side. So 16x squared minus 12x equals 12x minus 9. All right. Now we're going to move everything over to the left. So 16x squared, I subtract the 12x, so that gives me a 24x. And then I add the 9. Then I set that equal to 0. Okay, well, good. Okay, so now I have to factor this. Well, for 16, the factors of 16 would be 1 and 16, 2 and 8, 4 and 4, and this would be 1 and 9, and 3 and 3. So that's quite a bit of factors that I would have to run through. But I notice the first and the last term is a perfect square. So is this a perfect square trinomial? Again, this is one of those things that I went over in chapter 2 in the review section over factoring. So you might want to give it a look. Okay, so what do I square to get a 16x squared? Well, that would have to be a 4x. What do I square to get a 9? And that would have to be a 3. Okay, so let me remind you about this. A squared, sorry, A minus B quantity squared will multiply out into this form. A squared minus 2ab plus b squared. A squared minus 2ab plus b squared. Okay, so if that's the case, this 2ab I need to check. So here's the A. So 2 times 4x times 3. 2 times 4 is 8, times 3 is 24. X, I got the middle term back, so it checks. That's how it factors. And then I grab the sign of the middle. So 4x minus 3 quantity squared. So since this is a repeated factor, I only have one solution. And I'm just going to jump straight to my answer. Add 3, divide by 4. So I only have one solution, and that's the 3/4. Okay, so let me do this. If it's a plus b quantity squared, then it would be a squared plus 2ab plus b squared. Okay, but that's how you check to see if you have a perfect square trinomial. Okay, now we look at higher degree polynomial equations. Okay, so number 5, I look at all 3 of these and I notice they all have an x. 6, 11, and 7. Nothing in common, so I can't take a number out, but they all have an x. So I'm going to factor that out. And this is a degree 3. This isn't a quadratic. But when I factor this out, I get 6x squared minus 11x minus 7 equals 0. And now look at what you have left inside. Now you've got a quadratic inside, which means we can factor this. 7 only factors one way. It's 1 and 7. Okay, now I need my factors of 6. So what times what? Gives me 6x squared. So if I do a 2x and a 3x, well, the outside gives me a 14. The inside gives me a 3. 14 and 3, I can get an 11. 14 minus 3 is 11. Since I want a negative 11, then the 14, the bigger number, has to be negative, and the smaller number has to be positive. So now look how many terms you're multiplying together. We have an x times 2x plus 1 times 3x minus 7. So we set every one of these factors equal to 0. So there's one of my solutions is a 0. For this one, subtract 1, divide by 2. For the last one, add 7, divide by 3. Okay, so my three solutions are negative 1/2, 0, and 7/3. Okay. All right. Now, number 6, we have a degree 4 polynomial. Anytime you have 4 terms, we're going to factor by grouping. All right. So out of the first 2 terms, I can take an x squared out, and I'm left with a 2x plus 5. Now, the 2x plus 5 has to repeat. Okay, so 2x times what gives me negative 8x? And that would be a negative 4. 5 times what gives me a negative 20? That would be a negative 4. So that means I'm going to take a negative 4 out. Okay, so now we've got 2x plus 5 times x squared minus 4, whoops, equals 0, equals 0. Okay, now we're not quite done because the x squared minus 4 is a difference of squares. So x and x, 2 and 2, it's a difference of squares. So your signs, one's plus, one's minus, your signs are different. And we set those equal to 0. So now this is going to give us x equals, subtract 5, divide by 2. So negative 5/2. This one is going to give us a negative 2, and the other one gives us a positive 2. Subtract 2, and then the last one you're going to add 2. So we have negative 5/2. Nope, that's 2, negative 2.5, and then 2. And then negative 2, and then a positive 2. And those are our 3 solutions. Okay, now 3 solutions because look at the degree of your equation. It's a degree 3. That's the highest exponent. So at most, the degree of your equation tells you at most how many solutions you'll have. Okay, now number 7, I don't know why they didn't put number 7 first, but number 7 has already been factored for you. And all you have to do is list the solutions. So this one is going to tell you that x has to equal 3. This one is going to tell you that x has to equal negative 4. And this one, well, add 7, divide by 2. So that's 7/2. So our 3 solutions are negative 4, 3, and 7/2. And that was nice because it was already factored for us. We didn't have to factor it. Okay. All right. Now we've got 2 word problems to go through real quick. So here I would keep this sheet handy. Make sure that you go through this and know these formulas. You're going to need them. Okay. All right. So 8. It says the length of a rectangle is 1 inch less than 3 times the width. The area is 14 inches squared. I always suggest that you draw a picture because it helps. Okay. So this is the length, and this is the width. It says the length is 1 inch less than 3 times the width. So in order for me to know the length, I first have to find out what the width is. So the width is going to be x. Now the length is 1 less than 3 times the width. So this is going to be 3x minus 1. Okay? Because the phrase less means subtract, than means that you flip this order, the 1 and 3 times the width. You flip it. And that's what we did. And then they told me that the area of this rectangle is 14 inches squared. Okay. Area of a rectangle is length. Area equals length times width. So the area is 14. The length is 3x minus 1. The width is x. Okay. So now we distribute. So this is 3x squared minus x. Now I need to bring the 14 to the other side. And I'm going to set this equal to 0. And I need to factor this. 3x squared only factors one way. So that's 1 and 3. So x and 3x. And for 14, the two numbers that come to mind are 2 and 7. All right, now let's check the outer and the inner and see if we get a 1. So the outer is going to be a 7. The inner is going to be a 6, and I can get a 1 from that. I need a negative 1, which means the bigger factor has to carry the negative sign. So here's where you get the 7, and then that has to be the positive one. So now we solve. So we get x plus 2 equals 0, which means x equals negative 2. And 3x minus 7 equals 0, which means x is 7/3. Now, what is x? What did we call x to be? We told x is the width. We assigned it to be the width. So I can't have a negative 2. The width can't be negative 2 inches. So we throw this one away. So the only one that's left is the 7/3. So my width is going to be 7/3 inches. Now I have to find the length. So the width is 7/3 inches. So I'm just going to plug the 7/3 in. Now don't panic, because look what happens to these 3's. They knock out. So 7 minus 1 is just 6. So that means that the length is 6 inches and the width has to be the width has to be 7/3 inches. Okay. That's it. That's how that works. Now, these examples have been nice because we've been able to guess. All right. But sometimes you do have to use the AC method. So you might want to make sure that you are good with that. All right. Number 9. Last one. One leg of a right triangle measures 7 feet. If the other leg is 1 foot shorter than the hypotenuse, find the dimensions of the triangle. So they told us exactly what kind of triangle that we are going to be looking at. They told me a right triangle. So I'm going to draw a picture. Okay, so here's my right triangle. All right, now this is a leg. This is a leg. And then the longest side, which is the side opposite of the 90-degree angle, is the hypotenuse. So it said one leg measures 7 feet. Okay, so this is 7 feet. It says if the other leg is 1 foot shorter than the hypotenuse, the other leg is 1 foot shorter than the hypotenuse. Well, to know this leg, I have to know what the hypotenuse is. So the hypotenuse is going to be x. This one is 1 shorter than the hypotenuse. Okay, so I have a right triangle and the hypotenuse, so that means I'm going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Now, a squared and b squared refer to the legs, okay? Which means c is going to be the hypotenuse. All right? Put hypot. Okay. So 7 squared plus x plus 1 squared equals x squared. All right, so this is 49. Now, don't forget this x plus 1 quantity squared means you have to expand. So you're going to have to FOIL. All right. So we have 49 plus, now we FOIL, x squared. Outer is an x, inner is an x, so that's a 2x plus 1. Okay, so we're going to clean up each side. So x squared plus 2x plus 50 equals x squared. I have to set this equal to 0. So when I do that, I'm going to move this x squared to the other side. But notice that when we do that, not only do we lose, not only is this side set equal to 0, but we lose. Okay, hang on a second. Oh, my fault. Not only does the right side equal 0, but we lost the x squared, which means we don't have a quadratic anymore. So that makes it really easy to solve. So we have this little linear expression to solve. Oh, this should be a minus, which means this is a minus. The 2x is going to be a minus. Okay. Minus. Okay, so now minus 2x equals minus 50. So x equals 25. So I know that the dimensions of the triangle is going to be 7 feet. The hypotenuse is 25 feet, which means this leg is 25 minus 1, so that's 24 feet. So 7 feet by 24 feet by 25 feet. These are the dimensions of the triangle. Okay. All right. So that's it for 3, 4.